Namaskar. Today we will discuss new distribution, that is normal distribution. This distribution was invented by de Moivre, Abraham de Moivre in 1753. Also, Gauss invented independently this distribution. Therefore, sometimes this distribution is also known as Gaussian distribution. But normal distribution is most common name of this distribution. From binomial distribution also you can derive normal distribution. In binomial distribution, if n is very large but probability of success or failure is not very small, then the limiting form of binomial distribution is normal distribution. In such a limiting form, that is normal distribution, is a continuous distribution. The probability density function of normal distribution is given by this formula. This is a probability density function of normal distribution. Fx equal to 1 upon sigma square root 2 pi e raised to minus 1 by 2 x minus mu divided by sigma whole square. Here x is our random variable and range of x is from minus infinity to plus infinity. Here mu is mean of the distribution, sigma is standard deviation of this distribution, pi 3.1415, this is a value of pi, e is Napier's constant 2.718. So this is the probability density function using which we can calculate probabilities related to normal distribution. Here fx gives probability that the values of x will lie in an interval. So actually to calculate probabilities of normal distribution, we require to study concepts of integration from mathematics. But in reality, we will use normal distribution tables to calculate various probabilities. Which are the properties of normal distribution? So this distribution is continuous distribution. X is known as normal variate and its range is from minus infinity to plus infinity. There are two parameters of this distribution. They are known as mu for mean and sigma for standard deviation. This distribution is symmetrical distribution. So in you know that in any symmetric distribution, mean, median, and mode are equal. Here quartiles Q1 and Q3 are equidistant from the median. These are some important results. In normal distribution, mu plus or minus sigma covers 68.27% of the observations. The mu plus or minus 2 sigma covers 95.45% observations and mu plus or minus 3 sigma covers 99.73% observations. So this is one of the most important property that makes normal distribution unique. In the limits of mu plus or minus 1.96%, 1.96 sigma, exactly 95% observations, and in mu plus or minus 2.58 sigma, exactly 99% observations are included. Using this concept, actually, chapter of testing of hypothesis is made, which is beyond the scope of this lecture, actually. Okay, all the odd ordered moments of this distribution are zero. Probability at x equal to mu is maximum in this distribution. So in a normal distribution, highest probability is near mean, and it is given by 1 upon sigma square root 2 pi. Okay, in this distribution, mean deviation is equal to 4/5 of standard deviation. The quartile deviation is two-thirds of the standard deviation. And the last property is sum of two independent normal variates is also a normal variant. The normal curve is always symmetrical and shape of the curve is always a bell shape. For different values of mean, the locations of normal curve differ, but it remains always bell shape. For large values of sigma, that means standard deviation, normal curve is more wide. So if standard deviation increases, the width of the normal curve, you know that normal curve is always of this type. So if the standard deviation is more, the curve becomes more like a Laticartic curve. So if the standard deviation increases, the width of the curve increases. But if standard deviation is not so high, the curve will be uh, curve has high thickness. Okay. So these are some properties that can be used. We will calculate examples of normal distribution only using this standard normal distribution because statistical tables for standard normal distribution are already available. So we can use that table and from that we can calculate various probabilities. So in normal distribution, Z equal to x minus mu divided by sigma. This thing is known as standard normal variate, and the distribution of this standard normal variate is called standard normal distribution. And probability density function of standard normal distribution is this. Fz is equal to 1 upon square root 2 pi e raised to minus 1 half z square. Here value of z is from minus infinity to plus infinity. Note that mean of standard normal variate is always equal to 0 and standard deviation of standard normal variate is always equal to 1. So to calculate probability, we require standard normal table and the standard normal tables are, let me show you, these tables are of this type. For different values of x, we can calculate various probabilities for the which these probabilities are actually areas of under the normal curve. So for the given value of x, we can calculate area. Here see A is area, but actually for our examples, A is for the probability. Okay. So see, this is the shape of normal curve as discussed above. This is a bell-shaped curve, and this curve is always symmetric around its mean. And probability calculations will be based on the uh, standard normal distribution table. Okay. See, there are so many important applications of normal distribution, and this is one of the most widely used distribution in statistics. So, normal distribution has very wide applications in statistics, but at present we will go towards some examples how we can solve examples of normal distribution. So let us go through some example. See, in this example, distribution of height of 1000 soldier is normal with mean 165 and standard deviation 15 centimeters. Question is, how many soldiers are of height less than 138 centimeters? Second is more than 198 centimeters and between 138 and 198 centimeters. See, here in this example, Mean is given to you. Mean is 165 centimeter and standard deviation is 15 centimeters. Mean means mu and standard deviation means sigma. Now, for the first question, number of soldiers of height less than 138 centimeters. So here our value is x1. Let us assume that x1 is 138 centimeter, and for that x1, z1 will be equal to z means our standard normal variate, and z is always x minus mu divided by sigma. Here we are taking x1, so here we are writing x1. So z1 equal to x1 minus mu divided by sigma. Value of x1 is 138, mu is 165, and sigma is 15. And what we will get 138 minus 165 upon 15 equals minus 1.8. Now this number is negative. In standard normal distribution, middle point is always 0, and here our value minus 1.8 is negative, and therefore this value will be on the left side of the curve. What we require here? We require the values which are less than this number minus 1.8. So this is our normal curve. This point z1 is minus 1.8 and we require this value. How we will calculate this? Z1 is minus 1.8. We will find value of Z1 from the normal distribution table. Z1 is minus 1.8, but our table of standard normal distribution always gives us values for positive numbers. We have to observe 1.8 in the column of X. See, there are X. In this table, you can observe that there are three columns of X, and this table is distributed over 2-3 pages. Okay, so in the column of X, you have to find out value 1.8. So let us find value 1.8 in the column of X. See, in the column of X, yes, here in this column of X, there is this number 1.8. And what I will do is, I will find area corresponding to this. A means area, and this A is our probability. So for 1.8, A is 0.46407. See, the name of the table is normal areas and ordinates. We require only areas, not the ordinates. So actually at present in our scope of syllabus, this column of y is actually these are ordinates, but we will never use this column. We will use only the column of A, means area. So for 1.8, this number, this value is 0.46407. Okay. So how I will calculate this probability? I know that in normal curve, total area bounded by normal curve is always equal to 1. Total area bounded by normal curve is always equal to 1. Out of 1, area 0.5 will be on the left side of the curve, and area of 0.5 will be on the right hand side of the curve. So area from 0 to minus infinity will be 0.5, from which, from the table I got area between 0 to 1.8. From the table what we will get? Area from 0 to this point. 0 to this point area was 0.4641. So actually we require this area only. So how I will find out this area? I will subtract 0.4641 from 0.5. So from this point 0.5, if I subtract this, I will get this. So probability z less than or equal to minus 1.8 will be equal to 0.5 minus 0.4641, and which will give me 0.0359. Okay, so what is that number? This is probability that a soldier is of height less than 138 centimeters. Now, out of 1000 soldiers, there are total 1000 soldiers, and any soldier is with a height less than 138 is a probability that any soldier has height less than 138 is 0.0359. So, out of 1000 soldiers, there will be 1000 into this probability. That will give me 35.9, and which is approximately equal to 36. So I can say that there will be 36 soldiers having height less than 138 centimeters. Now the second question is number of soldiers of height more than 198 centimeters. So here let us assume that x2 is equal to 198. For that I will require z2. Z2 will be x2 minus mu divided by sigma. Mu, and after putting values of mu and sigma, I will get this number 2.2. From this, from the table of normal distribution, I will find value corresponding to 2.2. So let us find out area corresponding to 2.2. Area corresponding to 2.2 will be this. See here, area is 0.48610. So I will use this probability 0.48610 in my example. So 0.48610 is written as 0.4861. Now we require here number of soldiers of height more than 198. More than means we require the numbers which are greater than 2.2. Greater than 2.2. Greater than will be on this side. So we require the numbers of Z2 greater than 2.2. So we require this area. How I will calculate? From the area from 0 to infinity, that is 0.5, I will subtract area between 0 to 2.2. 0 to 2.2, and that was 0.4861 that we observed from the table. So if I subtract, I will get 0.0139. And from this, I can say the number of soldiers having height greater than 198 centimeters is equal to 1000 into the probability that we calculated, and that is approximately 14. Okay, now the third question. Third question is number of soldiers between 138 and 198 centimeters. See, we first calculated number of soldiers less than 138 centimeters, and in second question we calculated number of soldiers having height more than 198 centimeters. So we know that this two numbers 138 and 198 are already used for previous calculations. Uh, Z1 was calculated for x1 and Z2 was calculated for x2. So actually we require area between minus 1.8 and 2.2. So we require area between these 2 points in this question. Now we know that from the normal table, area between 0 to minus 1.8 was this, and area from 0 to 2.2 was this 0.4641, and this will equals 0.9502. And therefore, out of 1000 soldiers, if I multiply 1000 with this probability, I will get 1000 into 0.9502 equal to approximately 950. So there will be 950 soldiers that are having height between 138 and 198 centimeters. So this was the answer. So I think you uh, understood how we calculated probabilities. Now see the next example. In this example, 10 unbiased coins are tossed 500 times, and we require probability of getting 4 heads using normal distribution. You know that similar examples were in binomial distribution, but here we are going to use normal distribution because calculation of this example using binomial distribution is tedious, maybe tedious, you will feel. So 10 coins are tossed 500 times, so there will be number of coins are 10, P and Q in coin examples related to coin unbiased coins are given, so we will take probability of head equal to 1 by 2 and probability of tail also equal to 1 by 2, and total number of trials are 500. Now what is mean of the distribution? You know that in binomial distribution mean mu is always equal to np. N is 10 and P is 1 by 2. So mean mu is equal to 5. And our standard deviation in the case of binomial distribution, formula to calculate standard deviation was square root of NPQ. And N is 10, P is 1 by 2, Q is also 1 by 2. So our standard deviation is uh, square root of 2.5, that equals 1.118. So we want to calculate the probability of getting exactly 4 heads using normal distribution. Now 4 is a discrete number, and we know that normal distribution is a continuous distribution. So first we have to convert this 4 into a continuous variable. How I can convert 4 in continuous variable? So for that I have to subtract zero point 0.5 from 4 and I have to add zero point 0.5 in 4. So after making our x equal to 4 continuous, x will be lying between this interval 3.5 to 4.5. And now we will require this probability since we want to calculate probability using normal distribution. So now here lower limit is, let us denote lower limit by x1 and upper limit by x2. We already calculated mu and sigma. So let us convert x1 into z1 and x2 into z2 by using the mu and sigma that we calculated here. So if I use this 5 and 1.118, I will get Z1 equal to minus 1.34 and Z2 equal to minus 0.45. So actually I require these both points are negative. See, observe that these 2 points are negative and therefore we require area between these two minus 0.45 and minus 1.34. So both these points are negative. Now, this table is made only for positive values. So first I will find out this number, that is area between 0 and 1.34 from the normal distribution table. Area corresponding to 1.34 will be this 0.40988, and now area corresponding to minus 0.45. Area corresponding to minus 0.45 will be here. Area A 0.17364. So we observe this table 0.1736 after rounding. This is also after rounding. Now what I will do to calculate, I will use this logic. From this area from between 0 and 1.34, that is 0.494099, I will subtract area between 0 to Z2, 0 to Z2, that is 0.1736. So this subtraction will give me this probability, that is 0.2363. So expected number of heads, that is we require probability of x equal to 4. Our total trials were 500 into 0.2363, and that will give us the number approximately equal to 180. So this is how we calculated a continuous probability for a discrete probability distribution, since binomial distribution was a discrete distribution. Okay, now these two examples were very much straight examples, and I expect that in most of the examinations, most of the examples are straight. But sometimes some paper setters ask this type of examples also. Here, in an examination, minimum 40 marks for passing and 75 marks for distinctions are required. In this examination, 45% students passed and 9% students obtained distinction. Find average marks and standard deviation of this distribution. So actually, in this example, we require values of mu and sigma. Actually, we require calculation of mu and sigma. So let us suppose that mu and sigma are mean and standard deviation of the distribution. Since 45% students are passed, that means that probability of passing is 0.45. Minimum marks for passing are 40. And therefore, we can say that probability that x greater than 40, since to pass the examination you require minimum 40 marks. So probability of getting marks greater than 40 is equal to 0.45. Now, for this x1, z1 will be x1 minus mu upon sigma. So this can be written as x1 is 40. So I can say this is 40 minus mu over sigma. Okay. So let us denote this point by Z1. So we know that probability of Z greater than Z1 is 0.40. We don't know value of Z1, but we will find this Z1 using the table of normal distribution. So we know that area between 0 to infinity is 0.5. If I subtract This total area is 0.5. Now, if I subtract 0.45 from zero point 0.5, I will get area between this. I will get area between 0 to Z1. So the area between 0 to Z1 will be equal to 0.05. Now, for area 0.05, Z1 will be 0.125 from table. But how? Let us understand how. See, area is equal to 0.05. So I will open the table of normal distribution. I will observe the column of A, area, and in this column, I will try to find out 0.05. So let us observe and let us find 0.05. See here, this point is approximately near to zero point 0.5. See, this point can also be said that you can also say that this point is also near zero point 0.5. So what they are doing is they are taking average. They are taking this average. So average of these two number is 0.125. So from that I can say that Z1 is equal to this point, 0.125. So I can say 40 minus mu over sigma is 0.125. If I cross multiply sigma with this and do some simple mathematics, I will get this type of equation. Mu plus 0.125 sigma is equal to 40. Now, I am writing this is equation number 1. Now, 9% student got distinction. So you can say that probability of getting distinction is 0.09. 9% equals, in probability terms, it is 0.09. Okay. Minimum marks for distinction are 75. So that means that probability that x greater than 75 is 0.09. Let us denote this by Z2. Here Z2 will be a standard normal variate. That means x minus mu upon sigma. Here value of x is 75. So Z2 will be equal to 75 minus mu upon sigma. And that number is 0.09. Now, let us assume that this point is actually on the right hand side of the curve, because here is distinction. Here is our value of Z2 actually. Okay, so how I will find out? To calculate the example, actually I require this area. I know value of this area. This area is 0.09. So zero point 0.5 is area between 0 to infinity minus 0.09 will give me this area, that is 0.41. So area between 0 to Z2 is equal to 0.41. Now, how I will use this value 0.41? So once again, I will check the normal distribution table. I will observe the column of A, area, and I will try to find out 0.41 in the column of A. A means area. So here you can see that this number 0.40988 is approximately equal to 0.41, and for that area in the column of x the point is 1.34. This point will be known as Z2. So Z2 is equal to 1.34. What was our Z2? So our Z2 was this 75 minus mu upon sigma, and from the table we are getting, just a second. So we observed value for Z2 equal to 1.34, and for that we will make this one more equation, that will be 75 minus mu upon sigma equal to 1.34. If I simplify, I will get this type of equation, and that will be denoted by equation number 2. And by solving these two equations, as the as we were solving in previous standards, by solving these two equations, I will get sigma equal to 28.8, and I will get mean equal to 36.4. So this is how you can calculate mu and sigma from the given probabilities. So there are more such examples in this exercise. You can go through all this, and you can solve the examples related to normal distribution. Thank you very much. Thanks for listening.